right, we're moving to almost the last section of chapter 4. We are almost going to test. Next week we will be testing. Our topic is 4-6. Lesson 4-6, we're going to talk about functions. You've heard it. You've heard functions. We just created function equations yesterday. Your learning target, you're going to be able to identify different parts or characteristics of a function. So, some vocab words aligned with functions. Domain. When you think you are master of your domain. The domain is all x values. Remember, x is the independent value. Y always depends on x. That means x is like the master of its domain. Okay? It rules the world in functions. So domain is the x value. Your range. What do you think the range would be? Y. Range then is the y values. Write this down. You need to know this. So domain is x. Range is y. Okay? Relation is a set of points. Relations is a set of points. That means this is how it looks. You'll get some bracket thingy, and then it's going to have a relation, a different set of points. So we'll have like 1, 2, 3, 4, 5, 6. That's a relationship. These are like a group. They're a set. Make sure you write everything down. This chapter is so important. I can guarantee you're going to be referencing it for your tests that will be coming up. This is a biggie. Put some kind of bullet by it. I don't care how you make your bullet, but you need to know the definition of a function. A relationship is a function if for every x value, there is exactly one y. So for every x, there's exactly one y. And how you need to think and visualize this, remember function machines back in the day? Pretend this is a function machine. Okay, it's really weird. Huh?
We did this in 6th grade.
Yeah. And imagine that you get a number 1 that goes inside. And let's say that we're doing something to 1. So 1 comes in and let's say it's x plus 2. What's 1 plus 2? 3. 3 comes out. So 1 goes in, 3 comes out. That's a function. It's following a rule inside a machine. But if 1 goes in, can you also get -4 to come out? Yes or no? Is 1 plus 2 -4? No, that makes the machine would be broken. Okay? A function machine is saying you have a rule in here, and whatever x comes in, you're only going to get one value. Only one value is going to come out. If 2 values come out for one x, the machine's broken. We don't care how many, this is supposed to be x's. We don't care how many x's, it's just one y. For each x, there should just be one y. Okay, so ways to write an ordered pair. You know of it this way, x and a y. That's a point, the x value and the y. Well, we just said that x is actually a domain. Y is actually a range. Put the arrows there so your eyes know. And then we just talked about a function machine. And when you put an x inside, we're actually inputting the x. And what comes out, the output, is actually the y. And then remember when we talked about independent and dependent, and we're looking at a coordinate plane, The x is independent, y depends on the x. So x is independent, y is dependent on x. Notice that with the function machine. I just can't say y is going to be 7. I would need a 5 to go in here. Y depends on what I put x, the value I choose for x. Okay, next. This is one of the things you'll be doing. You are going to list each domain and range separately, and you only list it once. So if it's a repeating value, just list it one time. So how it'll look, you'll be given, remember this is a relationship, because it's a collection of points, a relationship. I'm going to say, okay, domain. This is how I do it, my domain. Domain is x. So I say, what are my different x's? I have a 3. I use a bracket. I have a 3. What else do I have for x? 4. What else do I have for x? 5. What else do I have? That's my domain. Those are my different x's. Write it down. Other page. My range. What value is my range, x or y? Y. So I do the bracket again, and I list my different y's. What's a y that I have? 4. What's another y? 7. What's another y? 9. And I only write 1 9, because I see the other one's 9. I don't repeat it. So my domain is 3, 4, 5, and 7. And my range is 4, 7, and 9. Domain x, range y. This is a comma here. Okay, I want you to identify the domain and identify the range for this next relationship. Okay, so my domain is my x's. So my domain is, the x's that I have are 6, 4, 6, but I already said 6, so I don't include that one, and 8. So domain is 6, 4, 6, I already wrote 6, I don't write it again, and 5. Those are my domains. My range is going to be my y. Range is y. My range is 5, 3, 4, 8. Domain and range. Identifying domain and range. One of the main learning targets. A huge learning target on MCAs and 8th grade standards. Huge power standard. So you have to make sure that you domain x, range y. And it's not too bad, right? I mean, the process is pretty decent. Just list the x, list the y, do not repeat them. Okay, then we bump it up a little bit. We bump it to what's called a mapping diagram. What we do with mapping, remember map is like connecting cities and states. It's the same thing for functions. You connect x and y's. So you connect x to its corresponding y. Okay, so when we map, we need it as a T-chart. So I usually go x, actually domain, x is domain. When we talk about functions, we talk about domains. So domain and range. And usually domain, how a lot of times we write it, we do like a little rectangular box, the domain and the range. Okay, so domain, x's. Of this first relationship, I have a 3, I have a 4, I have a 5, I have a 7. Those are my domains. My range is 4, 7, 9. Do I write 9 again?
No.
No. Okay. Now I map. And this isn't too bad. 3 goes to what? What does 3 go to? 4. What does 4 go to? What does 5 go to? 5 goes to 9, right? 5 and 9. 7 also goes to 9. That I mapped it. That's called mapping. Okay? I connected it. Okay, I want you to do the next one. Domain, range, rectangular box. And I want you to list out the domain and range and map them, connect them. So again, domain are my x's. Domain, ladies, are my x's. A point is an x and a y, an x and a y, an x and a y, an x and a y. So domain are my different x's. I have a 6, I have a 4, I have a 6, I already wrote the 6 down, I don't need to do it again, and I have a 5. Range, wise. So I have a 5, I have a 3, I have a 4, and I have an 8. Now I map, I connect it, but I go to the relationship. So I go back up here to see what gets connected to what. So here it says connect my 6 to my 5. 6 goes to 5. Connect my 4 to the 3. 4 goes to 3. Connect my 6 to a 4. I go back to the 6. 6 goes to 4. And I connect my 5 to the 8. 5 goes to 8. Now I have to, given a mapping diagram where I made the mapping diagram, I have to determine is it a function or not. And that's from our vocab words before. A function means that each x goes to exactly 1 y. Each x goes to 1 y. So I look, and I look at my x's. Well, here, let's define not a function. Sorry, let's define not a function too. Not a function then, if a function means x goes to 1y, not a function would be x goes to more than 1y. X goes to 2 or 3 or 4. It goes to more than 1. If x goes to more than one thing, that means when you put something into a function machine, multiple values are coming out, and that means your function machine is broken. So I look at each x. This x is going to one thing. This x is going to one thing. This x is going to one thing. I know that because there's one line connected to it. This x is going to one thing. So this relationship would be a function. I would write function. X went to one thing. One line was connected to each x. The next one. How many things does 6 go to? 2. Nope, can't happen. So this would be not a function. That means when I put 6 into a function machine, 2 things are coming out, and the function machine would be broken. Remember, there's a rule inside the function machine, and only one thing should come out when you put that rule in. So it doesn't matter. Look at the y's. It doesn't matter. This y, 2 things are connected. That doesn't matter. It only matters about the x's. So you're looking at the lines connected with the domain. Okay, so we're going to apply this. We're going to, given a relationship, that means a collection of points, we're going to identify if it's a function or not. How do I identify if it's a function? I create a t-chart and I map them. And then I look to see if my x is going to 1y. Okay. I want everybody to write third, see if x has one line.